Hello, everyone. Welcome to today's co-presented webinar, Navigating the Service Mesh Ecosystem. Today's a special treat because we have participation from both Buoyant and Red Hat, hopefully to help clear up any questions you may have around the many options that exist in the Service Mesh ecosystem. We're going to get started in just a few moments, but first I want to cover a couple of housekeeping items for today's webinar. The Crowdcast interface has a few ways in which you can interact with us. First and foremost, we're going to have a Q&A portion at the end of the webinar. So to ask a question, find the Ask a Question section at the menu bar that's at the bottom of your screen. When you click Ask a Question, you'll be able to submit questions that we're going to answer during the Q&A portion. I encourage you to submit questions as you have them throughout the webinar as they come to you so that we can be sure to address them at the end. There are a lot of folks on today's webinar. We hope to get to all of your questions, but we know that there might be many and we only have an hour. So I also encourage you to upvote questions that matter to you most as they come in. When you see questions, there's going to be an arrow you can click on and you can tell us what matters to you. You'll also notice that there's a chat interface for Crowdcast. You can use chat to quickly shoot us a message if you need to. But any questions that you want answered should go into the Ask a Question interface. That way we can capture them, we can ask them, we can address them, have them upvoted, and they don't just vanish into the ether, especially when we record this webinar and reshare it. So that's it for housekeeping items. With that, let's go ahead and get started. Christian, do you want to say hello and tell us a little bit about yourself?
Hey, thank you guys for joining. This is awesome. My name is Christian Posta. I'm a senior principal architect at Red Hat, and I work with our North American customers, helping them understand how to build resilient distributed systems and covering lots of different technologies, lots of different libraries.
Awesome. Thanks, Christian. And I should introduce myself. My name is George Miranda. I help run community here at Buoyant. I'm an engineer by background. I have been facilitating this webinar, and I'll also be participating in today's discussion, so wearing a lot of different hats today. There's a lot to cover, so let's just go ahead and jump right in. Actually, before we get started, I especially want to thank Christian for participating today. This webinar is a direct result from a conversation that was happening on Twitter during KubeCon in Austin last December. And the comment on Twitter was that with so many options, it wasn't clear where folks should. While to take off the vendor hats and do something together. Christian happened to pop by the Buoyant booth. We chatted about it, and here we are today. So I guess there are two takeaways there. One, Twitter is a really great way to engage with us directly, so there are Twitter handles. And two, we're going to try to be as vendor neutral as we can today and focus on how to help you, our audience, figure out how to make sense of all the different options in the ecosystem today. So with that, let's talk about what a service mesh is, right? What is a service mesh? Why do I need one? Why are there so many options for this now? Hopefully, you're already at least a little familiar with the solution. But in case you aren't, we're going to cover it briefly before we dive in deeper. So service mesh is a dedicated infrastructure layer for handling service communication to make it visible, manageable, and controllable. And the shift to microservice and cloud-native architectures solves many new problems, but it also exposes others, right? In monoliths, you have three-tier type architectures. And when you start decomposing those and building out microservices, service-to-service communication suddenly explodes, right? You introduce this whole new class of communication, often without thinking about it. And as it turns out, right, that whole new class of communication is often the most fundamental determining factor for how your apps are going to behave at runtime. And so you really quickly slam into all sorts of problems in production, right? Everything from dealing with the sprawl of dozens or even hundreds or thousands of distributed microservices to realizing that those services are often managed by different teams working on different schedules, right? And so when running in production, it's not always clear where service requests are coming from or where they're going to, or even what the relationship now is between different components of your applications. And that presents a pretty significant runtime challenge, right? So development teams have started to solve for some of these issues by building and embedding custom monitoring agents and control logic, debugging tools into their services as communication libraries. And then, they embed those libraries into another service and another, right? And where you end up is you have all these tightly coupled, difficult to manage embedded solutions. And that's pretty much an anti-pattern for cloud native, right? But it happens because in this new approach, right, the fundamental factor, again, for how your apps behave at runtime is now service communication. And we need to manage that. We need to deal with it somehow. And so the service mesh exists to help solve those operational runtime challenges, right? And I think that's why we're seeing so much interest in the space now. But how does that come together? How does it work, right? What kind of common things can we expect? Christian, do you want to add to that and maybe tell us, how that starts playing out in practice?
Yeah, let's do that. So let's look at the service mesh architecture. George laid out a couple of very fundamental aspects of the problems that we'll be solving. Let's look at what a breed of solution might look like. So if we go to the next slide, we're going to be looking at a set of infrastructure that is laid out kind of like this, as a visual diagram of what it might look like. Where in the green boxes, oh, go back, please. Oh, in the green boxes, we'll represent our applications, and in the blue boxes, we'll represent this service mesh stuff that we keep talking about. These are the control points or the access points in this network or in this cluster through which we can deliver value. If you go to the next slide. So we're talking, so this is living outside of the application, I think, is the first point that I want to make. That this is application infrastructure. And usually when we think infrastructure, we think middleware, networking services down, at lower levels of the network stack and so on. But this is application infrastructure where the support scaffolding understands application semantics. So think requests. Applications think in terms of requests or messages. And these are not the typical networking constructs that you think of, like packets or frames or whatever, right? So we in this infrastructure, we built a level of understanding that is application aware, and this provides services. This infrastructure provides services, things like how to deal with networks that are jittery, networks that are dropping requests or dropping packets or duplicating them, or are really slow. So things like retries and timeouts and circuit breaking. These are important aspects of dealing with the network at the application level. Now, the way we do this, or the service mesh kind of works, is that the application requests flow through these proxies, these very smart, intelligent application level or application aware proxies that end up enabling this extra capability, circuit breaking and retries and timeouts, like I mentioned. Now, as traffic is flowing through the proxies, and we saw it in a previous slide where the proxies might be co-located with the application itself. It doesn't have to be, but if it is, we can kind of imagine that all the applications are talking to each other and are going through these proxies wherever these proxies might live. Now, as your cluster starts to get bigger and you start doing more complicated things, we need a way to control and manage these proxies. And in a service mesh, the control plane is the part of the architecture that allows us to do that. So understanding, so when we have these proxies between our applications, we can get telemetry back from these proxies and get a deep understanding about what's happening at the application level on our network, which is huge. Now we don't have to be afraid to build these service-oriented architecture type applications. So again, the control plane is used to configure and manage the behavior of these proxies that live in the data plane in the service mesh. The next slide. Now, as George touched on, we're going to deployment models in containers and building microservices and so on. These networking problems tend to amplify because of that. But in the past, we still had applications talking over the network, right? We still had client server. We had things like message-oriented middleware and things not long ago like SOAP services and Corba and RMI, these different RPC type technologies. So we had this problem back then. So what did we do? Well, in a lot of cases, we tried to build client libraries that would ignore this fact that we're talking over the network. They went to the extreme of making it look like these are just local calls. Don't worry about the network. 95% of the stuff is going to be okay. But then when you hit that 5%, those were outages. And I would also argue that we've had different technologies that have tried to solve this in different ways, like message queuing. How many of you in an enterprise environment have used messaging to do request reply? Put a message on a queue and listen to another queue for a response. Now, this is a form of service discovery and load balancing that we would expect in our application networking infrastructure. And the message queue would do that. Load balancing really is just, the queue gets deep. You got, you just spin up more consumers. If things fail, well, the libraries typically automatically retry. Service discovery in the sense that, well, we don't really care what the consumers are. It's just, they'll find the messages, right? And then we went on to things like enterprise service buses, where we said, well, we have all the messages flowing through these message queues already. Let's just add some business logic to it and do some transformations and do some more complex routing. And that started to go down the path of the enterprise service bus. And more recently, we've seen things like API gateways pop up to provide some of this application networking stuff capability. But we've also seen vendors try to stuff more of that business logic back into the API gateways, a la the ESB. Finally, we're in the microservices hoopla and so on. There's been a lot of discussion about things like Netflix OSS and the myriad of libraries that they built. Things like Twitter Finagled that built the resiliency aspects and these networking aspects directly into the libraries. And George started to touch on that. And this is different. Service mesh is different insofar that we're still solving some of these same problems, but we're doing this in a decentralized way, which I guess the resiliency libraries did too, but we're doing this outside of the application. So we're not relieving the developer of having to know about these concerns. This is absolutely should be top of mind, but the developer doesn't have to implement that and co-tangle that with their application business logic. So if you go to the next slide. So as you start to look at this technology and consider how you might adopt it or whether you should adopt it, here are a handful of questions that you might want to ask yourself. Next slide. Because the reality of adopting any technology is more than just how one or two, a handful of developers really feel about it. Are you ready, not you as a single developer or a single architect, but is your organization ready for this type of technology? It's exciting stuff. Everybody's talking about it. But just like any hyped technology, you got to figure a way to cut through the hype and kind of dampen your enthusiasm and ask yourself, do I have the problems that a service mesh solves? And will this thing bring value to me? And this involves understanding your context, which only you'll be able to do, and understanding how the technology works. Does it fit with the way your organization works, and trying it out yourself, really, and evaluating whether or not your organization is equipped and ready to operate something like this. Next slide. Do you tend to favor centralized or more decentralized implementations of these functions? If you don't have a very large services architecture deployment, does it make sense to go through the complexities of using sidecar components for everything? Would it make sense just to have a pool of shared or centralized proxies through which these features, these capabilities can be added? Very similar to the way we look at the functionality provided by an API gateway. And once you start going down that path, you start to think, well, where does the API gateway fit, and where does the service mesh fit? So there might be some ambiguity or conflict there in how you adopt these different solutions. Now, in general, just a quick touch on the API gateway. API gateway is typically tied to, it doesn't have to be, but is typically tied to much bigger, more lofty goals with API management. And the things that API management does and the capabilities that it brings is not the same as service mesh, whereas the API gateway has some overlap, right? Things like specifying developer policies and rate limiting and retrying and certain security flows, developer documentation, and these types of things are very API management tooling focused. Now, some of that stuff can be implemented in API gateway and in service mesh, but API management is still a totally different thing. Next slide. So what functionality do you already have? Do you have things like service discovery, registries and libraries and so on to facilitate that? Client-side load balancing or circuit breaker libraries that you may have in your applications? Can you introduce a service mesh safely without disrupting or introducing more complexities or unknowns about how your system will operate once you've introduced the service mesh? And you'll have to evaluate this on a case-by-case basis and think through that. Next slide. What level of observability do you have today, and where are you trying to get? So evaluating this in terms of things like logging and tracing and metrics. Where are your gaps? Where are you comfortable? Are you able to expose this to developers or SREs or system service operators? Can they see and can they make intelligent decisions based on this? Or is this all just pulled into a operation, a separation of operations and developers, where the operations folks can see this high level telemetry, but the developers can't make any decisions on that? So I think these are important questions to ask. What is your goal? What are you trying to enable, and what are the ways your teams work? Now, once you're able to tackle some of those high-level questions and strategy, then you can start thinking about digging a little bit deeper. And George has some more direct questions to ask with respect to that.
Yeah, thanks, Christian. Yeah, I think where I want to take this next part is maybe a little more pragmatic, right? I'm a recovering infrastructure engineer before SRE was a title. And I think because of that, I always tend to ask basic operational questions first. And I think the same thing applies when looking at a service mesh. So the first question is, what platforms do you need to support? Right? And that might seem like an obvious question, but the devil is in the details, right? Is your entire stack running, for example, in Kubernetes, right? Do you need to stitch together connectivity between those greenfield apps and your legacy applications? Some products in the cloud native space, focus specifically on platforms like Kubernetes, for example. And that's a double-edged sword, right? That platform-specific focus can really help optimize for users of a particular platform and really kind of bring that experience together. But in a heterogeneous world, right, sometimes that might leave you in unmanageable situations depending on what you need to manage, right? So the question here is really, what is your topology like? What do you need to manage in production? And, where does that stuff run, right? Like, that is not a trivial question, and it actually matters quite a bit. What problems are you having today, right? And I think Christian did a really good job of sort of exploring this a bit. And I guess to echo that a little, I know we all want to play with the fancy new hotness, right? But these solutions come at a cost, right? Every time you implement a new tool, there's a new cognitive burden associated with learning that new tool, figuring out how to use it, how to maintain it, how to deploy it, right? How to keep it running well. And the question here is really, is the juice worth the squeeze, right? And we talked about this in the Are You Ready section. But I think the next question after that is, where does it actually hurt today, right? I think some features look really great on paper, but are you actually going to use them, right? Is this a pain point that you really have? Like, sure, this thing might be able to help you funnel select production traffic directly to your laptop, right? But is that a problem that you need to solve today? I think from my experience, I can tell you the last thing Christian was talking about in terms of observability, that tends to be a really big pain point for a lot of organizations. And that's one of the first places where they usually find value in a service mesh. So I think a really important question when approaching this space is, what specific pains are you experiencing today, right? So stop to gauge those and prioritize solutions that maybe speak to those first. Division of responsibilities is an interesting one, right? I mean, that's basically Conway's law, right? Organizations that design systems are going to produce a design whose structure mimics that of the organization itself, right? I mean, it's kind of unavoidable and it rings true, right? We build systems that work the way that we work. And so when you're looking at different options in the space, I think a really good question is, how opinionated is any given tool about how it expects teams to interact, right? The service mesh occupies this interesting space where it decouples runtime communication management from application code, and it pushes that into the underlying infrastructure. But who's supposed to manage that, right? What is the division of responsibility between your development teams and maybe like the folks doing deployments and releases and the operations teams that manage outages and implementation of InfoSec policies, right? Who's responsible for that? Who's expecting to interface with the settings and the capabilities of a service mesh, right? Does the tool that you're looking at work for the way that you expect to share and manage those responsibilities? I think that's a very critical component and a good question to ask. And then rounding out the pragmatic questions, right? Support. We're looking at open source projects today. What are the support expectations for your organization? Are Slack and GitHub enough? Do you need commercial support? Is that an option? What is the development community like around the project that you're considering? And there's no one universal answer here, right? But it's certainly an important question, though, not the only one, of course, and there's a reason that it's at the bottom of my list. But in a nutshell, right, I think those are some of the introductory questions that you should be asking yourself. And the answers, of course, vary from organization to organization, right? Projects have different scopes and different areas in which they best shine. And there's no one right answer for which speaks best, right? But I think this is a good starter guide, right? Ask yourself some of these questions we've gone through, and then start considering your options in the ecosystem. So next, we're going to look at a landscape of the open source service mesh options that exist today. And you may note when we do this that there are other, quote unquote, service mesh solutions out there, but they tend towards closed source. So today we're going to be focusing on 4 completely open source solutions in chronological order from when they were released. We're going to look at Linkerd, Envoy, Istio, and Conduit. So with that, let's start by looking at Linkerd. So Linkerd is sponsored by Buoyant, right? And Linkerd was the first modern tool to use the term service mesh for this class of solution, meaning that Linkerd originated the category, right? But Linkerd has its roots, as Christian was talking about, in the early days of Twitter and the Finagle library. William Morgan had a great talk about this at KubeCon in Austin, the service mesh, past, present, and future. I really highly recommend that talk if you want to dig into origin stories, but I won't belabor the point. Go check it out if you want to learn more. But here's the basics, right? Linkerd has been around since February of 2016. Happy second birthday, Linkerd. And that means that Linkerd has seen a tremendous amount of production adoption. Companies like Salesforce and Fox, Monzo, PayPal, other large-scale web companies. So Linkerd is battle tested and it has the production scars to prove it. But if you think about that, right, Linkerd is 2 years old. Kubernetes is only 3 years old, right? So Linkerd was born in a time when we saw an explosion of container management platforms. And so it has pretty wide support for many of them, including, raw Docker support and, support for VMs and like bare metal if need be, right? Like it'll basically run anywhere. And the idea behind Linkerd is that it's written to be like very powerful and incredibly feature rich with a lot of flexibility over things you can do and deployment options. But there's a lot of fine-grained control that you get with a tool like Linkerd, right? It inherited a lot of functionality from Finagle. And so, it was built on lessons learned from scaling out Twitter's massive infrastructure, right? It was designed to handle many of the problems inherent to distributed computing long before Docker was even a thing, right? Before cloud native was a thing. And so like the challenges of running distributed services at scale have always been a thing, right? It's just that now more of us are dealing with those same types of problems. And so Linkerd has the things in it that you would expect, right? Things like built-in service discovery. It was designed to work across many different platforms. Not all of them have their own service discovery. Or, if they do, tools and abstractions were written around the ones that do. So you could use a common mechanism across those platforms in Linkerd. It has latency-aware load balancing, and which means that rather than looking at, layer 3 and layer 4 heuristics, Linkerd can more intelligently distribute load based on service request performance at layers further up the stack. It includes built-ins to manage resilience, like the ability not just to set retries, but to also recognize if it's safe to retry particular options based on what's actually contained in that service request. So it includes built-ins to mitigate cascading failures that result from long retry loops, right? And so when you decide to retry a particular request, if it fails, right, that retry sits there in a loop tying up resources, and those retries can stack and stack and stack, right, until the entity that's queuing up those retries also itself fails, right, which then creates another stack of retries and another failure, right, and so on and so on. So Linkerd gives you things like retry budgets and circuit breaking to help mitigate that. And then, all of that happens without your apps, being any wiser, right? In fact, rather than coding that into your apps, it all happens transparently. You make plain old RPCs in your apps, and when it goes over the wire, Linkerd does the rest, right? And because everything happens when we're transmitting over the wire, you can do things like protocol upgrades, code a remote call as a regular HTTP call, and then have Linkerd worry about upgrading that connection to use TLS, right, and make sure that all remote communications are encrypted. You get a bunch of other things, rich metrics, indivisibility, distributed tracing with tools like Zipkin, right? There's a custom DSL that helps you set nested rules for how traffic should get routed down to the individual per request level, right? Linkerd basically gives you a ton of fine-grained control that you didn't have by default before. But here's the thing, right? Linkerd scales up incredibly well, meaning it'll do tens of thousands of requests per second per host, and you can get pretty tremendous throughput. But it's a heavyweight solution, right? It's hard-hitting and feature-rich, and sometimes that's entirely what you need to do, and you need that level of control. And when you do, Linkerd is a great choice, right? But it has a lot of horsepower behind it. One thing that I want to touch on before we move on is that Linkerd is also like a full service mesh solution when we were talking about a data plane and a control plane. I think because Linkerd has been around for so long, it predates some of those distinctions and clearly labeled components that show that. So some folks mistakenly think that Linkerd is just a data plane proxying solution, right? But if you look at Linkerd, it includes the named component, which is Linkerd's control plane. And that's where you do things like set up routing rules and compose policies. And, that's where they live before they're read from the data plane. But I think there's some confusion because Linkerd did some proof of concept work back in July to, like, for example, plug in just the proxying components of Linkerd into the Istio control plane. And while that's certainly possible, that's not how folks have used Linkerd in practice. There's a lot more to say, but I'm looking at the clock and realizing that we need to move on. So I'm going to hand it to Christian to tell us a little bit more about Envoy.
Thank you, George. If you'll go to the next slide. So Envoy proxy is a project that was started at Lyft, the ride-sharing company, back in May of 2015, but it wasn't open sourced until October 2016. And it had been used, so I guess now it's been in Lyft in production for quite a while, over 2 years, I think. The last numbers I heard were like 4 million queries per second. But what's interesting is that since it's been open sourced, the community has swelled around it and has been pretty excited about it. So for the last year and change or so, we've seen contributors from Google. Google's been jumped in pretty hard, and I say a lot of the top contributors to Envoy are from Google, and we see and it is used in production at very large internet companies, and these are the public ones. So there's probably a handful more private ones. So obviously Lyft and Google, Verizon and Stripe and eBay and Booking.com and so on. But it is a service proxy, and it is built specifically with performance and stability in mind, especially at high load and high scale. So it's built with C++, and it is highly performant, and at large amounts of load, and especially when you start to chain a bunch of requests together, the unpredictability of your services in general, but then you throw in application infrastructure proxies like these data proxies, these data planes. You want to be a little bit more deterministic, as much as you can, a little more sure about what the tail latencies, what those outliers would look like, and Envoy takes that into consideration up front with its design. It is ultimately a level 3 network, level 3, level 4 filter, and what that means, it shuttles bytes back and forth, and it has a plugin architecture for building application-aware filters on top of this byte processing. So out of the box, we get things like HTTP and HTTP2. So we're able to understand requests and retry requests and do that type of stuff at that level. But there's also filters built for binary protocols, things like MongoDB or Dynamo, and I think there are people working on filters for Kafka and so on, and we'll probably see this list grow, where we can get introspection or understanding of what's happening, not just in the services that talk HTTP or gRPC, but all the way down to when you're communicating with the database. It uses an API for being able to do hot deployment or hot configuration at runtime. You don't have to take any restarts or any of that stuff. And because of its performance profile, is amenable to the shared proxy or the co-located proxy or sidecar proxy deployment models. And this allows to do interesting things like mutual TLS. One of the biggest pains in the butt is setting up and operating mutual TLS between services. And Envoy allows to be able to secure the transport layer with mutual TLS, and since you can deploy it with a sidecar, you can have the TLS terminated as close to the application as possible. And if you're inside a Kubernetes in a pod, for example, and it's terminated inside the pod with the application. And another interesting point about Envoy is that it is we've seen the community gravitate toward it and build around it, but there's interesting proxies that are being built on top of it. So, for example, the folks at Tigera and Cilium, they're building their networking security constructs on top of Envoy. And just recently, we see Solo.io release their new function-aware proxy built on top of Envoy. So it understands serverless functions and functions within within applications at a much higher level of an application. Next slide, if you could. So if we look at options like Envoy as a, this is the data plane. These are the service proxies through which all of our applications are communicating and sending traffic. By itself, the Envoy is not a service mesh. Envoy is the proxies, so the data plane level. And where, I'm sure maybe you've heard of a project called Istio. Istio provides that control plane, or the ability to manage these things in a cluster, these Envoy proxies in a cluster. Istio was, I think it was started back in December 2016, but didn't actually launch publicly until May of 2017. And it was started with Google, Lyft, and IBM. I think some of the initial design was based on IBM's Amalgamate project. But so Istio launched in May with those three companies, like I mentioned. But again, this is another community that's expanding and growing, and we're seeing lots of people interested either running it themselves, running it in production, or contributing to it and bringing it in as part of a product. So I work at Red Hat, and we're looking at bringing in Istio as part of the OpenShift platform. But there are other companies like Weaveworks or Tigera, Pivotal, so on, that are building this into their products. And although I will give a heads up, in my opinion, Istio is not something that would be ready to put into production today, but may not be that far off. There are people who are running it in production. So again, Istio provides a control plane for our service proxies. It brings this clustering semantics for understanding what's going on in the service mesh or in the data plane. It's built on a couple of components that provide authentication type capabilities, configuration type capabilities, and integration with backends. And I'll talk a little bit about that when I talk about observability and policy control. So one of the first capabilities that you might want to do inside of a cluster, if you have this cluster semantics, is finally control the way traffic is flowing through the cluster. So you might want to do this to separate out releases and deployments, where traditionally we've seen deployments and releases kind of coupled or commingled, where we bring a new version of our application into production and we do a rolling upgrade, and that new version starts to take on new traffic. With Istio, we're able to, since we can see and control that traffic, we're able to decouple the release and deployment actions, where new deployments into production, getting new code into production, don't necessarily mean that it's taking on traffic. We can do things like canary releases and just funnel off a small percentage of traffic into our new deployment, which constitute a release. And we can do things like we can develop cohorts or buckets or groups of different users that we might want to expose to the new deployment gradually. So we have these graduated rollouts or releases. So we can control the traffic between the different versions of services. Now, this isn't just at the ingress point or the edge. We tend to think user application, okay, well, we can do this type of control at the edge. But once calls get into the cluster and services start communicating with each other, we're able to apply this routing control even deep within the cluster, not just at ingress. Istio, through its authentication component in the control plane, allows us to securely, we're able to bring certificates and mutual TLS and identity to the workloads that are running inside the mesh. The auth component is responsible for generating these certificates and allowing them to be brought into the application, and the data plane then uses that to enforce mutual TLS. Istio can be responsible for also rotating those those certificates out periodically so they don't go stale. And since we're able to assign identity to these workloads, we're able to do role-based access controls and define what services are allowed to talk to what other services. So we looked and we talked about the data plane proxies supplying features like load balancing, circuit breakers, rate limiting, timeouts, retries, that kind of stuff. And through Istio, we're able to configure that across the cluster and get those features out of the box. So we don't have to make any application changes. Just from an API or a CLI, we can say, well, for this service, this workload over here, we're going to have circuit breaking at 5 failures in 5 seconds or whatever. We can have very fine-grained policies about how the circuit breaking happens inside of the applications. Now, the last couple of things are interesting. There's a component inside of Istio that is responsible for enforcing policy and streaming back telemetry. Information like request failures or number of requests per second, and including things like who's trying to access the services. So we're able to bring this telemetry back into a component in Istio called a mixer, and syndicate that data. These are the number of requests that are happening. This is who's doing these operations. Here are distributed tracing spans, and so on. We're able to syndicate this data back into data backends. So now each individual service doesn't have to try to integrate with those, one at a time. But we have a central location, a central point of integration where we can include things like Prometheus. Get the metrics into Prometheus so that we can view them in Grafana or whatever, or Datadog, or get logging into whatever logging system we want with FluentD, or StatsD, or whatever. So we have this mechanism for observing and understanding what's happening in the cluster, inside the service mesh. Equally important is the ability to restrict access or restrict based on policy what services are allowed to talk with each other. A very interesting component that integrates into Istio's mixer is the open policy agent, which going forward will allow us to have very, very complex business policies implemented in an open policy agent, but enforced through the service mesh. If you can go to the next slide. So we looked at Istio as a service mesh that runs, I forgot to mention, it runs in Kubernetes or outside of Kubernetes, it doesn't matter, but I'll let George explain another open source service mesh called Conduit.
Thanks for that, Christian. Yeah, so that brings us to Conduit, right? And Conduit is also sponsored by Buoyant, and it is definitely the newest of the bunch. Conduit's a really fun project, and it's one that I'm personally excited about. And the first question I almost always certainly get with Conduit is, why did Buoyant make another different service mesh? Don't you already have Linkerd? And we do, right? Like, we do have Linkerd. And Linkerd is a great tool, but right tool for the right job, right? Just because in your garage you've got a ball peen hammer, that doesn't mean that there's no need for a sledgehammer or a rubber mallet, right? Or even one of those tiny little hammers you see in jewelry repair shops, right? Different use cases, different tools for different scenarios. So Conduit came about when we asked ourselves at Buoyant, like, what have we learned? What have we learned from almost 2 years of supporting production service mesh use cases? Right? Like, what problems are people having the most, and where are they getting the biggest value, right? And most importantly, like, what parts of a service mesh are they actually using, right? And based on that, like, what if we could build something super useful that just did those things, and in return was super simple and easy to use, right? And what we found is that with Linkerd, sometimes you need like big, powerful, hard-hitting, heavyweight solutions, right? The complexity of your environment demands it. But with great power comes great responsibility, right? And so when you need that, you're going to dive in deep, right? You're going to take on that responsibility. You're going to do what it takes to get a big solution like that going out of sheer necessity. But not everybody has those needs, right? And what we found with production service mesh users across the board was that they wanted a few things, right? They want service mesh to be fast, right? Don't introduce additional noticeable latency. They don't want a performance hit in order to gain the benefits that a service mesh provides, right? Like performance is king, right? So it's got to be fast. They want it to be lightweight, right? Because again, we're putting these proxies everywhere. Maybe, we're running them like as Kubernetes daemon sets or like, one per host, or maybe we're running them as sidecars, right? So these things have to be small and not take up a lot of your resources. And they want the service mesh to provide, those things that we've been talking about: visibility, basic resiliency controls, right? Some sort of reasonable auth and security model, right? But all of those things, like folks generally seem to not want that to get in their way. So what we got is Conduit, right? And Conduit has a radically different approach. So the approach with Conduit is designed to be ultra light, which is to say that it has an incredibly small resource footprint. It's meant to be fast. It's crazy fast. So the data plane is written in Rust, which provides a number of benefits, not the least of which is just blazing fast performance from using native code, right? It also provides very solid, predictable performance in ways that basically make Conduit, perform with sub-millisecond P99 latency. Conduit's also lightweight, right? Which means it has a very small footprint for the proxies themselves, generally like averaging about a meg in size. But when I say that Conduit is lightweight, right, it's not just lightweight in terms of resources. It's also cognitively lightweight. There aren't a lot of moving parts to Conduit. Like it has a very simple, easy to understand architecture. It's got that Rust-based data plane, and it has a Go-based control plane where extensibility would occur, like through a plugin model. And if you're interested in the internals and how that all comes together, we have a previous Conduit webinar where we dive deep into the internals of the Rust-based data plane. So I won't belabor that too long, but I kind of like to call Conduit minimum viable service mesh, right? Which basically means it's designed to be zero config, right, and just work out of the box and be as simple and approachable as possible. Because like not getting in your way is not just about performance and resources, right? It's also about being clear, with no hidden magic, so that you can reason your way through issues when they happen in production, right? And Conduit is designed to minimize introducing new additional complexity into your systems. But that comes at a cost, right? That also means that Conduit has stripped out a lot of the extraneous features, right? Like instead, it only focuses on core use cases that we think solve real problems for real users today, right? Not everybody needs that big heavyweight complexity that can come with a service mesh, right? Some folks just need that small ball peen hammer, right? Not a sledgehammer. And for those folks, there's Conduit. Conduit's still really in its early stages, right? We're at the 0.3 release. We just released in December, right? So far, we've mostly focused on handling all traffic out of the box with near zero config, right? Whether it's H2, H1, all TCP traffic, right? It supports gRPC. And we've also focused on giving you constructs to help with observability, right? To give you those top line metrics and help with troubleshooting. You can also see the other things that are on our roadmap. But if you look at what the project's been doing, we've been releasing every 2 to 3 weeks, and we're moving pretty remarkably to quickly flesh out that feature set, which you can see here, right? Like everything on the slide, we expect to have by the end of April, and it's already February. So, you can see though, even from what's on the slide, that's not necessarily the full set of features that you might find in a solution like Linkerd or even Istio. But it covers the core use cases that are critical without a whole lot of complexity behind it, right? And we still support features like automatic TLS, right? And certificate management, rotating keys, exporting those metrics to Prometheus, right? We think there's a core set of places where folks tend to get the biggest value out of a service mesh, and that's where Conduit is focusing today, right? So Conduit is also, as Christian mentioned, as we were talking about during the transition, today Conduit is only specific to Kubernetes, but if you're a Kubernetes user looking for small, lightweight, and easy, then Conduit might be for you. Check it out, conduit.io. You can see what's on the roadmap. There's a great getting started guide, and that gives you an idea of where it is we're going and the types of things that we'll be covering with Conduit. So with that, right, we come to a summary for today's webinar, right? And as you can see, all of these solutions have different use cases, and I think different places where they focus their energy, and they have some pretty distinct fundamental philosophy differences, right? And each has a pretty particular place where it shines. So hopefully that gives you a good whirlwind tour of some of the options and sheds light on what might be best for your particular needs. So remember, right, your environment and your stack, they have unique requirements. The list that we talked about today, the questions that you should be asking, they're a great place to start, right? And hopefully between a look at all of those questions, right, and the options that we just went through in the last section, you can feel a little better equipped to start figuring out where and how to get started on your journey with the service mesh. But I would also say this, right? I think we'd also encourage you to try multiple options, right? And do your due diligence. And though this may help you figure out where to get started, right? The proof is really in the pudding, right? The rubber meets the road when we actually start using these things in our environments and seeing how they're going to work for us. So give them a shot. Let us know what you think, right? These are all open source projects with very vibrant communities and pretty open channels for feedback. And so that brings us to the end of the presented portion. I want to take a little bit of time before we get to Q&A just to thank Christian for joining us. When we were chatting about doing this webinar together, I think the thing that was very clear to me is that Christian really cares about doing right by users. And we both happen to work for vendors in this space. But first and foremost, I think we're both very motivated to help users solve the problems that they're having and less so with pitching our particular solutions. So thank you for that. I'm glad that we were able to present this webinar together.
Thank you, George. And thank you, Buoyant, for helping put this together. I definitely believe that the service mesh that's the direction of building this type of solution to the problems we talked about. But I do want to caution that although the pattern is sound, let's move this networking stuff out of the application. Just be careful. Let's not repeat the same mistakes or drawbacks that we had with things like enterprise service buses or some of the API management implementations, where we started jamming too many things into this pattern and had to deal with the drawbacks. But I, just like George said, I encourage you to check out all of the different open source projects we talked about today and get involved in the communities. I think getting involved in the mailing list, asking questions on the GitHub issues, opening up bugs, these are all very valuable contributions to the communities.
Awesome, thank you for that. So we hope you've enjoyed this co-presented look at the service mesh ecosystem. The session is being recorded, and we'll share both the recording and the slides in a follow-up blog post after we wrap up today. So with that, we still have some time for Q&A. So we'll go for questions and start with the most popular. So the first question here is Conduit en route to becoming a CNCF project? And I can answer that one. It is our intention to contribute Conduit to the CNCF as well. There's a process for that. There are a number of things that we need to do. It's still a relatively new project. That is our intention, yes. So although I'm not sure how exactly en route we are right now or how much we could say that, right? That's our intention. It should get there, and we are pushing for that. So I hope that answers the question. This next question, can Istio or Conduit be used without an orchestrator like Kubernetes or some other option? Can we run them on bare metal? Christian, do you want to take that one? And then I have something to add also.
Yeah, so Istio is not, although the initial platform was Kubernetes, and of course I think Kubernetes is going to be the best place to run applications, it's not tied to Kubernetes. Istio is built with APIs and abstraction in mind, insofar that you can swap out proxies, you can swap out platforms onto which you deploy it, and VMs or bare metal is a first-class citizen in this deployment model.
Cool. I think for Conduit, if you look at what Conduit is doing, Conduit is very specifically tied to Kubernetes. And part of the reason that we've been able to keep it so simple and lightweight is that same double-edged sword that I was talking about in terms of optimizing for a particular platform. We're using a lot of Kubernetes built-ins. The Kubernetes API is very sophisticated, and we're trying to leverage it wherever we can, so we don't have to reinvent the wheel. And that has come with a lot of additional simplicity. But for Conduit today, right, that means that it is very, very bound to Kubernetes as a solution. If you look at Linkerd, for example, right, that's an alternate approach for being able to run it without an orchestrator of any kind, right? You could run it on bare metal. I've seen folks use it in tandem with Console. There are integrations for a lot of different ways to deploy it. So if that's the use case you're going for, I would say that that might be a more appropriate option to look. And let's see. We have a couple of questions about, yes, this webinar is being recorded. We're going to share it. There's a question. If I understand correctly, Envoy runs as a sidecar. Any plans to make it run as a daemon set in Kubernetes environments?
Yeah, so that is quickly clarify, I think, a little bit of the question. So Envoy runs as a sidecar with Istio. That's the default deployment today. Envoy itself is a standalone proxy that can run as a sidecar or run as a shared proxy as a daemon set, or however you want to run it. But today in Istio, it runs as a sidecar. Now, there's nothing that precludes. There's nothing in the architecture that precludes from deploying this as a daemon set. I don't think that's been a top of mind use case at the moment. But please jump in. Open up an issue, tag me, and we can continue the discussion in GitHub.com/Istio.
Cool. Let's see. We have, I think, time for one last question here. Can we provide a link to the presentation about the REST-based data plane? Yes. We're going to go ahead and take a little bit of time to write this up, do some brief conclusions about the webinar, share the link, share the slides, and again, if you have any questions that come to you after this, feel free to reach out to us. I think all of the projects have their own Slack groups. So come find us directly or ping Christian and I on Twitter, and we'll be happy to take some more questions there. So thank you very much. You should see a recording for this webinar using the same link that you used to join Crowdcast momentarily, and you should see that follow-up blog post sometime later this week. So thanks, everyone.
Thank you.